Good afternoon. Today we are going to see the sheet number 4. Already we are with sheet number 1, sheet number 2, sheet number 3, and now we are with sheet number 4. Now if you will see in the continuation of this sheet, we have first, that is hot road section, that your DSS start from this. Then you have to classify this section so that you will coming to know that what values you have to consider, that is for area. Then you have connections, so we have these connections. After this connection we have tension member, we have compression member, and for compression member we require buckling class and effective length. For tension member calculation we require this your age. Here we need not require anything, but for compression member we require buckling class, this classification which is related with AE, we require buckling class. This classification also we require, and effective length. So if you will see the continuation, then you will understand it, how these sheets we have plotted. Then we have actually these list and batten columns. So after these compression members, we have, that is column. So column, and for this column, we have this slab base, we have this gusseted base, and effective area of this. Already I mentioned that we have not studied this, not related with our syllabus. So we have column, then we have slab base, and then we have gusseted base. This is your unit number 3. So this part, if you will see carefully, we have this part, that is unit 1. Then we have this part along with this column. We have this part, that is unit 2. Then we have this part, that is in unit number 3. So we are going serially, and now we are with these flexural members, that is unit number 4. Actually, this eccentric connection we do not have in our syllabus, but this we require for gantry girder, and that is prerequisite. You should know about it. So now in flexural member, we are going to see different section for flexural members: laterally supported, laterally unsupported, wave buckling, wave, and this is not buckling, actually wave buckling and wave crippling. So we have to go with these 4 parts in section number, your sheet number 4. So we will directly switch over to the your sheet number 4. So already we have gone through 1, 2, 3, and now we are with 4. So cross sections, if you will see, then we are generally not using angle sections. In flexural member, we are going to prefer, that is symmetrical. Symmetrical sections we are going to consider in flexural members. And then we have built up section. So this built up section we are going to prefer flexural member, that is for gantry girder. And we will see why we will prefer this in gantry girder itself. But we have to require ZP top more, and therefore we are going to be with this. Why ZP top more? Because we have lateral and longitudinal stresses which are in top flange, and therefore we require to resist it, that is section modulus greater in our top portion, that is above neutral axis. Then if load is very large, span is very large, then we require, that means already bending moment is very large, we will go with built up beam sections. And then plate girder, we are already with this in unit number 6. Plate girders we are going to use for low or medium loads, but with a larger span. And there we are going to use these flexure members. So we should know these beams we are going to use for less bending moment, that is load is less, span is less. We will go for this. If little increase in this, then we will be with beam with plates, then for gantry girder. And then when bending moment is larger, we will prefer welded plate girder. And after that, we will go with these double beam sections. Then we have laterally supported and laterally unsupported. So already we have seen this laterally. So you can see this. This laterally supported and unsupported. You may have question. This is related with your compression flange. Means he may ask, in laterally supported beam, your compression for flange or tension flange should be laterally supported. So tension flange that is not considered in laterally supported or unsupported. Your laterally supported and unsupported deals with your compression flange. If your compression flange is restrained against lateral buckling, restrained against lateral buckling, then we are going to say laterally supported. So here you can see this. And this flange, this we have not restrained against lateral buckling. Not restrained. So here you can see a beam may be assumed adequately supported at the support provided the compression flange, this is most important word, has full lateral restraint and nominal torsional restraint at support supplied by web cleats. Partial depth end plate, so that is full lateral restraint to compression flange relates with full strength. So FBD value we will say full strength in this case. So this is laterally unsupported. So this diagram is laterally unsupported and this is laterally supported. Do not say top flange and bottom flange because he may ask you a question that you have cantilever beam. And in that case, your flange, that is top flange or bottom flange, should be laterally supported or restrained. So if I have cantilever beam, in that case, my bottom flange should be laterally restrained because in that case, we have top at tension, bottom at compression. So if you will see this beam, then this beam is going to deflect in this fashion. So compression bottom, tension top. So we have to restrain, that is bottom flange. So do not answer top flange and compression flange. Answer that is top flange and bottom flange. Answer compression flange and tension flange in this way. So you can see this may be in this fashion or this may be in this fashion. Both we are correct. Here we have to provide connectors. And these connectors have developed bond between your slab and your beam. Now purlin we have again laterally supported because your purlins, if I will consider angle section, then that angle section top leg, this is connected to your sheets through J bolt. Through J bolts, we are going to connect sheets with purlin. So your purlin becomes laterally supported. So you can see these connectors we have shown over here, known as shear connectors. So this is laterally supported, laterally unsupported. So now we have next web buckling and web crippling. Now you can see where we have web buckling. So we have web buckling, that is below concentrated load. Below concentrated load. Now you may say we do not have concentrated load over here, so you cannot apply load at a point. So when you are going to show in oral, you have to show a small portion, and this we can say base width B. And through that width, so because if we will sit also, our load is concentrated load, but we require some space to sit, and that we are going to say as base width. So this is concentrated load only, but with some base width, and that becomes your UDL in that base width. Now buckling, always we have that is at center. So now you can see this diagram. So buckling we have here, that is at the center, at neutral axis I can say. Here maximum buckling we have. And then according to IS code, we have to disperse that load at an angle 45 degrees to the top point. And this becomes your base width. So we have this will be width. That is at critical section. And this will be your, if you will see, this will be base given and this will be h by 2 because angle is 45 degree. We have, if we have total h, then it becomes h by 2 and h by 2. So wave buckling, so should never confuse with this. Buckling is always at center of this beam. And now crippling, you can see this crippling, we have cripple means crush. So crushing of web, and this is buckling of web. Both are related with your web. Now why this crippling or crushing occurs? Because your load is transferred from larger area to smaller area at the junction of this web and flange, and there we have chances that our web may crush or web may cripple, and that is critical section. And we have to find critical section, that will be, this will be width of, or this will be a line of critical section by plotting slope 1 in 25, 1 vertical with 2.5 horizontal. And then we are going to be with this radius R1, this will be vertical, and then we have to find tan of theta slope, and that value you are going to get afterwards. So this will be B, and this you are going to get by using this 1 in 2.5. So 1 vertical, 2.5 horizontal. So this value you can say 2.5 into R1. That is root of radius. So not only R1, R1 plus thickness of flange, TF. So 2.5 R1 plus TF. Because we have this as root of radius. And this is my critical section. And this will be TF. Sorry, this will be TF. And bottom we have, this will be R1. So total we will get TF plus R1. And likewise, we are going to get these values, that is at critical section. Then we have eccentric connection. So we have detailed study of this eccentric connection, that is in your gantry girder. So he may ask you, show the force in bolt. So you have to keep in mind, as our moment is anti-clockwise, so this each FB should develop clockwise moment about center. Now he may draw the connection in this fashion, and then you have load here, and he may ask you, draw the FB value in this board. So you have to keep in mind, in this case, we have these boards. So FA value, we are in the same fashion. So likewise, but keep in mind, this is FA. Now for FB, you have to keep in mind. So we have FB. Here we have center of this, CG of this bolt group. Then we have to connect this. Now we have now moment that is anti-clockwise. So your force should develop anti-clockwise moment about CG. So my forces will be in this fashion. It will develop anti-clockwise moment. Then we have to connect this. It will be perpendicular to it, again anti-clockwise, and this is perpendicular. You have to keep in mind. Then for this, again we have to go anti-clockwise 90 degree, and here also we have to go perpendicular to this, and again develop anti-clockwise moments. So likewise, we have these 4 sheets. So you can see formula that is given FA square plus FB square plus 2FA FB cos theta. Our second formula already you have seen. And this resultant force in bolt should be less than your VDB, design strength of bolt. So our design strength of bolt should be greater to avoid failure. So these videos I have prepared for your 4 sheets. So now again I will just repeat. In first sheet we have that is rolled sections. Then we have in this classification. Then we have bolted connection. Then we have welded connection. In second sheet we have column, and then we have bases. Then in this gazetted base, slab base, and effective area. Then if we will go to sheet number 3, then this is again we have related with sorry, this sheet 2, we have tension member, we have compression member, sections for tension member, we have sections for compression member, then we have buckling class over here, and then we have last, that is effective length. And in sheet 3 we have actually that is column. In this column we have batten column, we have lacing, you should know steps of this. Then we have bases, that is slab base, gusseted base, and then we have effective area for bases. And just we have seen this sheet number 4. This is we have first flexural member, that in flexural member we have seen that different cross sections which we are using for this flexural member. Then we have crippling for flexural member, then we have buckling for flexural member, then we have eccentric connection in this flexural member. So likewise, just you have seen all these in your flexural member, that is main. Again we have that I have not mentioned, which is flexural members. We have laterally supported and laterally unsupported. So likewise we have this all. If you have any questions, any doubt, you can have my WhatsApp number, that is 70388316674. So if you have any query, this is it. So 70388316674. Any query, any doubt, you can ask on this WhatsApp number. So this is all about your first 4 sheet. Then in next I will go with other remaining 4 sheet. So I will stop here only. Thank you.